Hello to all. I'm Dr. Alkesh Agrawal, and in this lecture, I'll mainly focus on the digital multiplexing. So, this lecture mainly includes the discussion on fundamentals of time division multiplexing. Then I'll discuss about the role of electronic commutator. Then I'll discuss about the T1 carrier system. Then there will be discussion on synchronization and signaling of T1 carrier system. And then I'll explain you the TDM-PCM hierarchy that includes T1 to T4 PCM TDM systems that are also known as digital system 1 to digital system 4 signals. Here are some reference books that include Communication Systems by Simon Haken and Principles of Communication Systems by H. Taub and D.L. Schilling. So first of all, we'll discuss the block diagram of time division multiplex system. So in this slide you can see the block diagram, which is made in original on MS Visio. So here you can see we have the information that is coming from n individual channels. That is the user information that is being passed through low pass filter. And here you can see a commutator switch. So what is a commutator switch? This commutator switch it revolves at a rate of 8,000 revolutions per second, thereby maintaining the Nyquist criteria, because we know that sampling is being done at a sampling rate which has a standard value of 8,000 samples per second. So this commutator, which is taking out the samples of each user, it revolves at a rate of 8,000 samples per second. So in one complete revolution it takes one samples, and if we assume n is equal to 24, so we have the first standard is of 24 users. So in one revolution this commutator will take the samples of 24 users, and in the second revolution it will take the second samples of each 24 users, and so on. So like this, in 1 second we have 8,000 samples of each 24 users. Now these samples are being quantized and encoded through pulse modulator, are being transmitted over a communication channel. Then the reverse is being done, the demodulation is being done, and then we have a decommutator. What this decommutator does, it redistributes the user information onto the individual channels, and like this we have this whole time division multiplex system. Now in the subsequent slides we'll discuss in detail how all these processes are being implemented under this digital multiplexing standards. So this I have already explained that we have the standard for 24 users. So this commutator, it continuously sweeps the information from first to 24th user and back to n equal to 1, and this is done at a rate of 8,000 revolutions per second, thereby maintaining the Nyquist criteria of 8,000 samples per second of each signal. And in standard pulse code modulation system we have the 256 quantization levels. So being 256 quantization levels, each quantized level is being encoded in 8 bits. So if you see this diagram, you see that we have the sample from first channel, the sample from second channel, the sample from third channel, the sample from 24 channel. So if we see the first revolution, so we have the first sample from each 24 user, and each sample is being quantized and encoded into 8 bits. Why 8 bits? Because we have 256 quantization levels. So we have 8 bits. You can see with different colors: 1, 2, 3, 4, 5, 6, 7, 8. So like this we have information from second channel is also encoded in 8 bits. The information from third channel is also encoded in 8 bits. Like this we have 24 channels. So if we calculate, we have 24 into 8, that is 192 bits of information is obtained by one revolution of commutator switch. So the T1 frame, this is one frame of T1 standard. The T1 standard is for 24 users. So T1 frame has 192 bits per frame, that is depicted in this figure. So then there is a process of frame synchronization. So that is one extra bit is being added as framing bit. So now we in one frame we have 192 data bits plus one framing bit, that is 193 bits. And there is a sequence of framing bit which is depicted as 110 111 001 000. So this is a sequence of framing bits for 12 for the transmission of 12 frames. So after transmission and reception of 12 frames, these framing bits are being extracted and you know they are being compared. So if they are found to be the same, it means the synchronization process is perfect and the information is received exactly what is being transmitted. But if the sequence is not so obtained, then there's a request for retransmission of the information. So this process is called frame synchronization, where we can see that an extra bit is being attached with every frame, thereby transmitting 193 bits with a sequence of 12 frames as 110 111 001 000, and the sequence is being extracted for frame synchronization. Now we'll see how we calculate the bit rate. So here we can see the bit duration in bits is 193 bits, and these 193 bits, we know that the Nyquist criteria is 8000 samples per second, and in 1 second we have 8000 revolutions. So the time allotted for one revolution is 1 by 8000, that is 125 microsecond. So if we see the bit duration in frame is 193 bits, and in time it is allotted, the 193 bits are being allotted a time of 125 microsecond. So by this calculation, the data rate for transmission of one frame, it comes out to be 1.544 megabits per second. So this is the data rate for T1 carrier that all have to remember. So simple calculation, you have the transmission of 193 bits in 125 microseconds, so that comes out to be 1.544 megabits per second. Now let us discuss about TDM and PCM hierarchy. So what we have discussed is the T1 carrier. So here what we have discussed is we have 24 individual channels where the information is coming at a rate of 64 kbps, 64 kilobits per second, and they are being digitally multiplexed to generate T1 carrier. So the calculation for T1 carrier data is there's a transmission of 193 bits in 125 microseconds, so that comes out to be 1.544 megabits per second. So that is digital system 1. Okay, so this is the first level in the hierarchy. Now you see the second level. Now we have the digital system 2, DS2. So here you can see this is a standard for multiplexing 4 T1 carriers. So T2 carrier is generated when T4 T1 carriers are being multiplexed together. Now you can see the calculation of the data rate. So you can see in through one channel uh, there are transmission of 193 bits. We have 4 such channel, so that is being multiplied by 4 times. Plus there are certain extra synchronization bits that are being added, which counts to 17. So all this comes out to be 789 bits, which is 193 into 4 plus 17. So these 789 bits are again to be transmitted in 125 microseconds. So that gives you a multiplex data rate of T2 carrier is 6.312 megabits per second. So you can compare in T1 carrier the data rate is 1.544 megabits per second, which is being increased to 6.312 megabits per second. In T2 carrier, where 4 T1 carriers are being digitally multiplexed to generate T2 carrier at a data rate of 6.312 megabits per second. Now we come to T3 carrier. So in T3 carrier, which is a digital system 3, this is third level, where 7 T2 carriers are being multiplexed to generate T3 carriers. So we have this calculation for T3 carrier data rate. So you can see total we have in T2 carrier we have 789 bits. So here from each channel we have transmission of 789 bits, and we have such 7 channels. So into 7 plus 69 extra synchronization bits are being added. So total count we have 5592 bits. Again, these number of bits are again transmitted in 125 microsecond. So this calculation gives the data rate for T3 carrier is 44.736 megabits per second. So again, T3 carrier, in T3 carrier we have multiplexing of 7 T2 carriers, thereby transmission is at a rate of 44.736 megabits per second. Now we come to the highest level hierarchy, where is a generation of T4 carrier, where 6 T3 carriers are being digitally multiplexed. So you can see in T3 carrier we have the from each channel we have 5592 bits of frame. So in T4 carrier data we have from each channel we have 5592 bits. We have 6 such channels, so in multiplied by 6 plus 720 extra synchronization bits are being added. So total we have 34,272 bits, which is to be transmitted in again 125 microsecond. Thereby we have the T4 carrier data rate of 274.176 megabits per second. So you can compare, in T1 we have 1.544 megabits per second, in T2 we have 6.312 megabits per second, in T3 we have 44.736 megabits per second, and finally in T4 carrier we have transmission of 274.176 megabits per second. Thank you.